Okay, so welcome to another deep dive. This time we're tackling something pretty fundamental.
Hmm.
Clause 5 of this ISO standard, the IEC 2989.2022, and the reason we're focusing on this
Yeah.
is, well, it's all about AI concepts.
Yeah.
Basically, if you want to understand AI, you kind of need to understand this clause, right?
Yeah, it's a really great place to start if you're, somebody who wants to get a handle on AI,
Right.
but like without all the super technical details.
Yeah, exactly. So think of us like your instructors for today as we go through section by section and really unpack
Yeah.
the ideas in clause 5.
Like almost imagine it's like a syllabus for AI, like here are the key concepts
Yeah.
that you're going to need to know to really understand the field.
Exactly. And the cool thing is we're going to do it in a way that's hopefully pretty engaging.
Absolutely.
So, you're tuning in because you want to get a grip on this stuff, but you want to do it efficiently.
Right.
And that's what this deep dive is all about.
We're going to try and give you the insights and kind of, the surprising angles that you might not expect.
Yeah, keep it interesting, but also make sure you really walk away with a solid understanding.
Definitely.
So that's the mission today. Explain what each of these concepts in Clause 5 means, why it matters in AI, and how it all fits together in the bigger picture.
Exactly.
Right. So why don't we jump right in, starting with the very beginning,
Yeah.
Clause 5.1, which is simply titled General.
Right. So this section is really just kind of setting the stage. It's saying, hey, this is what this whole clause is about.
Yeah.
It's about giving you the basic terminology,
Right.
the basic descriptions of AI concepts. And it's kind of laying that foundation.
Yeah.
Before you can build anything, you got to have
Right.
the right words, the right understanding of what those words mean.
So it's like establishing that common language so we can then actually
Exactly.
have a deeper conversation. Okay, so with that groundwork laid, let's move on to 5.2, which is interesting because it talks about this shift.
Yeah.
In thinking from the ideas of strong AI and weak AI to the what seem to be more practical concepts of general AI and narrow AI, why this shift in focus?
So I think historically there was this big debate, especially kind of in the philosophy of AI,
Right.
about whether or not AI could ever really understand things the way humans do. And so you had this distinction between weak AI, which is basically like AI that could, process symbols,
Right.
manipulate information,
Yeah.
but without any real comprehension, like a calculator.
Right.
And then you had strong AI, which was, this idea that AI could actually achieve that.
It understands what it's doing, not
Yeah,
just
it understands.
process numbers.
It has a genuine consciousness, whatever you want to call it.
Right.
So that was the philosophical distinction. But the ISO standard kind of points out, okay, but that's not really that useful when we're actually trying to do AI research.
Yeah, it's too abstract in a way.
It's very abstract. And so they say, well, what's more useful is to think about the difference between narrow AI and general AI, which is really focused on what AI can actually do.
So less philosophy, more what's happening in the real world.
Exactly.
Okay, so let's break that down then. What is narrow AI?
So narrow AI is basically what we have today. It's AI that's very good at specific tasks.
Right.
It can often outperform humans in those very narrow domains.
Right.
So think about a recommendation system that can, suggest what movies you might like, or, an algorithm that can spot cancerous cells in medical images.
Right. Very specialized.
Very specialized, but very powerful within that domain.
So specialists as opposed to generalists. And that brings us to general AI.
Right. So general AI would be this kind of hypothetical AI that could perform any intellectual task.
Right.
That a human being can. So it would have this general intelligence that could be applied to any problem.
And the key point here is we don't have that yet.
We do not have that.
Yeah.
That's right. All of the AI we have today is narrow AI.
So very important distinction when people are talking about AI reaching human-level intelligence.
Exactly.
We're not there yet.
We're not there.
Okay. So that's a really helpful grounding.
Yeah.
Let's move on to 5.3, which introduces this idea of an agent. And this sounds like a way of modeling AI systems.
It is. It is. So the agent paradigm, as it's called, is this way of thinking about AI systems,
Right.
particularly those that are kind of designed to interact with an environment and achieve goals.
Right.
And, if you think about it from the perspective of AI, AI is basically the discipline of trying to build artificial agents
Okay.
that can exhibit what we call rational behavior. So taking actions that are going to lead to the best outcome.
Right. So it's not just about intelligence. It's about actually acting in the world.
Right. It's about doing things.
Doing things intelligently. Okay, so how does this agent interact with the world?
So the agent paradigm makes this distinction between the agent itself and the environment.
Mm.
And the agent interacts with the environment through what are called sensors and actuators.
Okay.
So the sensors are how the agent perceives the world. They're gathering information.
Right.
The actuators are how the agent acts on the world.
So sensors are like its eyes and ears, actuators are like its hands.
Right, exactly. Exactly.
Okay.
And the goal of the agent is to use the information from the sensors to choose actions, to achieve its objectives.
So it's a very like input, process, output kind of model.
Yeah, exactly.
Okay. And the document also mentions, and we don't have to go too deep into this, but it mentions that there are
Right.
different types of agents depending on their internal architecture, like how they're kind of built.
Exactly. So there are things like reflex agents, which are very simple. They just react to what they perceive. Model-based agents, which actually try to build a model of the world so they can predict what's going to happen.
Right.
Goal-based agents, which have an explicit goal they're trying to achieve. Utility-based agents, which are trying to maximize some kind of utility function.
Right.
And then learning agents, which can actually learn from experience and change their behavior over time.
So, a whole variety of ways of approaching how to build this intelligence.
Absolutely.
Okay, so let's move on to 5.4, which talks about knowledge.
Yeah.
And this feels like, this is a core concept.
It is. It is.
When we talk about AI,
Yeah.
what's the key distinction here that we need to understand?
So the key distinction is between information and knowledge.
Okay.
And, information is basically the raw data, the observations that the system receives. But knowledge is what the system extracts from that information. It's the structured, organized understanding that the system has.
So knowledge is information with meaning.
Exactly, exactly. So, you might have a bunch of sensor readings about temperature.
Right.
That's information.
Right.
But knowing that, a rapid drop in temperature combined with dark clouds and high winds means a storm is coming, that's knowledge.
So it's about making connections, drawing inferences, understanding the implications of the data.
Exactly.
Okay, and the document makes a couple of interesting points here.
Yeah.
It says that the same information can actually lead to different knowledge depending on what you're trying to do.
Right, right. So, if you're interested in whether or not you should bring an umbrella, that same temperature reading might tell you something different than if you're interested in whether or not it's safe to go for a hike.
Right. Different goals, different interpretations.
Exactly. And then the other point that it makes is that the same knowledge can be represented in different ways. So, you could have a rule-based system where you're representing knowledge as rules.
Right.
You could have a statistical system where you're representing it as probabilities. You could have a neural network where it's represented as these kind of connections.
Right. So different tools for different...
Yeah, different tools for different jobs.
Okay. So a lot of flexibility there. All right. So we get to 5.5, which talks about cognition and cognitive computing.
Yeah.
And this sounds very much like it's about how we think and learn.
It is. It is. So cognition is basically the process of acquiring and processing knowledge. And the document lists a bunch of different cognitive processes like attention, focusing on relevant information, knowledge formation, which is, how we learn and structure information.
Right.
Memory, obviously, retaining information.
Yeah.
Judgment, reasoning, problem solving, decision making.
Right.
And then language comprehension and production, which is, our ability to understand and generate language.
So it's taking all those things that we do as humans and saying, well, can we build AI?
Right. Can do that too.
Exactly. And that's what cognitive computing is all about. It's trying to build systems that can perform these tasks that typically require, human-level cognitive abilities.
So it's not just about processing data. It's about thinking, learning, reasoning.
Exactly.
Okay. So moving on to 5.6, which is semantic computing. What's the focus here?
So semantic computing is really about trying to get machines to understand the meaning of information.
Okay.
So it's not just about the words or the data itself.
Yeah.
It's about the underlying context, the intent.
Right.
If I say it's raining cats and dogs,
Right.
I don't literally mean
Right.
animals are falling from the sky.
It's raining a lot.
It means it's raining a lot, right? So semantic computing is trying to get machines to understand
Right.
that kind of meaning,
Right.
not just the surface level information.
So reading between the lines in a way.
Exactly.
Okay. And then we have 5.7, which introduces soft computing.
And this sounds like it's maybe a different approach to problem solving than traditional computing.
It is. It is. So soft computing is a set of techniques that are designed to deal with imprecision,
Right.
uncertainty, partial truth. And this is a big departure from traditional computing, which is all about
Right.
precise inputs, exact solutions.
Right.
Everything's got to be perfect.
Yeah, very rigid logic.
Very rigid logic. But the real world is messy, right?
Yeah.
So soft computing says, okay, well, we need to be able to deal with that messiness.
Right.
And the goal is not necessarily to find the perfect solution, but to find a good enough solution that's robust, that's cost effective.
Right. So embrace the uncertainty and the imprecision.
Exactly.
Okay. So what are some examples of soft computing techniques?
So you have things like fuzzy systems, which use degrees of truth rather than just true or false. You have evolutionary algorithms, which are inspired by natural selection. You have swarm intelligence, which is based on how, groups of insects or animals behave.
Right.
And then you have neural networks, which we'll talk about more later, but
Okay.
they also fall under this umbrella.
So it's like a toolbox for dealing with the complexities of the real world.
Exactly.
Okay. Let's move on to 5.8, which focuses on genetic algorithms. And this sounds like something that's definitely drawing inspiration from nature.
It is. It is. So genetic algorithms are a specific type of soft computing technique
Okay.
that's based on the idea of natural selection.
Mm-hmm.
So the basic idea is you start with a population of potential solutions to a problem.
Right.
And these solutions are often encoded as what are called chromosomes, which are basically just strings of data.
Okay, so like a digital representation.
Right, like a digital DNA in a way.
Of a possible answer.
Exactly, exactly. And then the algorithm evaluates how fit each of those chromosomes is.
Okay.
So how good is it at solving the problem? And then it selects the fittest chromosomes and it allows them to reproduce.
Okay.
So it combines their genetic information to create new offspring.
Right.
And then it also introduces some random mutations, which are just changes in the data.
So kind of like the random element.
Right, the random element in evolution.
In evolution.
And so this process goes on over and over again, and over time, the population of solutions evolves to become more and more fit.
So you're simulating evolution to find the best solution.
Exactly.
Okay, that's a pretty clever approach. 5.9 talks about symbolic and sub-symbolic approaches for AI, and this sounds like a very fundamental way of
It is.
categorizing how AI is developed.
So historically, there have been these two big paradigms in AI, symbolic AI and sub-symbolic AI.
Okay.
And symbolic AI is all about representing knowledge using symbols.
Right.
And rules and logical structures.
So very explicit rules.
Very explicit rules. So think about expert systems where you have, if-then rules.
Right.
If this is true, then do that.
So it's like programming the AI.
Exactly. It's programming the knowledge directly.
Okay.
And the knowledge is explicit, and often it's understandable to humans.
Right.
Sub-symbolic AI, on the other hand, is much more about learning from data. And it's not about having these explicit symbols and rules.
Okay.
It's about, the knowledge is kind of implicitly encoded.
So the AI figures it out on its own.
Yeah, so think about machine learning, particularly deep neural networks. That's where this approach really shines.
So it's like instead of giving the AI the answers, we give it the data.
Right, we give it the data and let it figure out.
And it figures out the answers.
Yeah.
Okay, so that's a pretty fundamental difference. And I guess the document makes the point that in reality, a lot of systems are using both.
They are. So modern AI often combines these two approaches.
Right.
You might use machine learning to do some pattern recognition, but then you use symbolic reasoning to actually make decisions based on that.
So it's a hybrid approach.
Just a hybrid approach, yeah.
Okay. Let's talk about something that is absolutely crucial for a lot of AI systems, and that's data, which is covered in 5.10.
Yeah, absolutely. You can't have AI without data, at least not most of the AI that we have today.
Right.
And this section really outlines the life cycle of data, from the very beginning to the end.
Okay.
So it starts with data acquisition. how do you get the data?
Right.
Where does it come from? Internal sources, external sources.
Right.
And then there's this really important point about assessing a bias in the data.
Right, because if you have biased data going in, you're going to
You're
get
not going to get biased results.
biased results coming out.
Yeah. So then you have exploratory data analysis,
Right.
which is basically looking at the data, trying to understand it, see if there are any patterns, trends, anomalies.
So just kind of giving a feel for
You're getting a feel for the data.
Yeah, what you have.
And then you have annotation, which is where you add labels or metadata to the data.
Right.
And this is particularly important for supervised learning, where the AI needs to know what the right answer is.
Right.
So you have to provide those labels. And then you have data preparation, which is, cleaning the data, transforming it, formatting it.
Getting it ready to be used.
Getting it ready to be used by the AI.
Okay.
Then you have filtering, where you might remove some data that's irrelevant or unwanted.
But again, being careful about bias.
Being careful about bias, exactly.
Okay.
Then you have normalization, which is about scaling the data so that it's all in the same range.
Mm-hmm.
De-identification, if you have personal information, you need to remove that.
Right.
And then quality checking.
Make sure it's good data.
Making sure the data is good, it's complete, it's accurate.
Okay, so a very thorough process to make sure the data is up to scratch.
Absolutely.
And the section also talks about different types of data that are used in AI.
Yeah, so you have production data, which is the data that the system actually uses when it's running.
Mm-hmm.
You have test data, which is used to evaluate the system before you deploy it.
Right.
And it's important that that's kept separate
Yeah.
from the data that was used to develop the system.
Right, so it's a true test.
A true test, yeah.
Yeah.
Then you have validation data, which is used during development to help you choose the best model.
Right.
And then you have training data, which is the data that's actually used to train the model.
Right.
So all of these different types of data serve different purposes.
Right, so it's not just data, it's, different data for different purposes.
Right.
Okay. So let's move on to 5.11, which talks about machine learning concepts. And this is a big area. So
Yeah, it is. It is.
What are some of the key ideas here that we should understand?
So this section gives a really good overview of the different approaches to machine learning.
Right.
So it starts with supervised machine learning, which is where the model learns from labeled data. So each input has a corresponding output.
Right. So it's like, here's the question, here's the answer, now figure out the relationship.
Exactly. So this is used for things like classification,
Mm-hmm.
where you're trying to categorize things into different classes.
Right.
Or regression, where you're trying to predict a continuous value.
Mm-hmm.
And then you have unsupervised machine learning, where the model learns from unlabeled data.
Okay, so it's just trying to find patterns.
Trying to find patterns on its own.
Yeah, so things like clustering, grouping similar things together, or dimensionality reduction, where you're trying to find the most important features.
Yeah.
Then you have semi-supervised learning, which is kind of a hybrid.
Right.
It uses both labeled and unlabeled data.
Okay.
And then you have reinforcement learning, which is this whole other paradigm,
Right.
where an agent is learning to interact with an environment,
Right.
and it gets rewards or penalties based on its actions.
Right. And then finally, there's transfer learning, which is about taking knowledge learned from one problem and applying it to a different but related problem.
All right, so it's like building on previous knowledge.
Exactly.
Okay. And then the section also kind of reiterates this idea of the training data and the trained model. The model is the thing that comes out of the learning process.
Right.
That's what's used to make predictions.
Exactly.
And then validation data, test data, again, really important for making sure that the model is actually doing what it's supposed to do.
Right.
And then finally, there's this idea of retraining, which is basically updating a model with new data. And there's this really interesting concept called continuous learning.
Yeah, continuous learning is really cool. It's basically where the model is constantly being updated as new data comes in.
So it's like it never stops learning.
It never stops learning.
Okay. Let's move on to neural networks, which is covered in 5.1. And this is, another one of those areas of AI that it is. There's a lot of excitement around.
A lot of buzz, yeah.
So what are neural networks all about?
So as the document explains, neural networks are inspired by the brain.
Okay.
They're trying to mimic the way that the brain learns and processes information.
Okay.
And so at a very basic level, a neural network is made up of these interconnected processing units called neurons.
Right.
And they're organized in layers.
Mm-hmm.
And the connections between the neurons have weights.
Right.
And the network learns by adjusting those weights.
Right. So it's kind of like strengthening and weakening the connections between the neurons.
Exactly. And then you have this idea of deep learning, which is basically just using neural networks with many, many layers.
Oh.
And this allows you to learn these very complex patterns, these hierarchical representations.
Right.
And it often can reduce the need for what's called feature engineering, which is where you have to manually extract features from the data.
So the AI is figuring out what's important on its own.
Exactly.
Okay. And then the document goes on to talk about some different types of neural network architectures, different ways of structuring these layers.
Exactly. So you have feed-forward neural networks, which are the simplest. Information flows in one direction from input to output.
Okay.
You have recurrent neural networks, or RNNs, which are specifically designed for sequential data.
Right. So like time series or natural language.
Exactly, where the order matters. And then you have long short-term memory networks, or LSTMs, which are a type of RNN that are really good at learning long-range dependencies.
Right. So remembering things that happened.
Yeah, remembering things from a long time ago.
A long time ago.
And then you have convolutional neural networks, or CNNs, which are really good at processing data that has this kind of grid-like structure.
Okay, so images or
Images, exactly.
things like that.
Yeah.
Okay, so a whole variety of tools.
Yeah, and then it also mentions Bayesian networks, which are these probabilistic graphical models that are used for prediction and reasoning under uncertainty.
Okay.
And then support vector machines, or SVMs, which are really good at classification.
Right, so, again, different tools for different jobs.
Exactly.
5.13 talks about autonomy, heteronomy, and automation.
Yeah.
And this sounds like it's about how much control the AI has.
It is. So it's about the spectrum of control.
Okay.
At one end, you have autonomy, where the AI system is making its own decisions.
Right.
Maybe even changing its own goals.
Right. No human involvement.
No human involvement.
Yeah.
And then at the other end, you have full human control.
Right.
And then heteronomy is everything in between.
Okay, so varying degrees of control and influence.
Exactly. And there's probably a table in the document that kind of shows how this relates to different levels of automation.
Right. So from no automation to full automation.
Exactly.
And there's a really interesting note in here that says that, autonomous might be a bit of a misnomer.
Yeah, it is.
Because even these so-called autonomous systems, they're still operating within the boundaries.
They are.
That were set by the humans who created them.
They're not making their own decisions in a vacuum.
Right.
They're still operating within a framework.
So it's important to keep that nuance in mind. And then the document also talks about some criteria for classifying a system. How much external supervision does it require? How well can it understand its context? How responsive is it? Can it operate continuously? Can it adapt and learn?
Right.
Can it evaluate its own performance? And can it actually make proactive decisions?
Right. So all of those things kind of factor into
how autonomous it really is.
And it also mentions these ideas of human-machine teaming and intelligence augmentation, which are really about collaboration rather than replacement.
Right. So AI working with humans, not necessarily replacing them.
Yeah.
Okay. And then the overall message here is that, as AI becomes more capable, it's even more important to think about.
Absolutely.
Accountability and oversight.
Yeah. Yeah, you don't want to just let these systems run wild.
Right.
Okay.
So 5.14, Internet of Things and Cyber-Physical Systems. And this is where AI starts to really interact.
It does.
In the physical world.
This is where it gets real, yeah.
Yeah.
So this section is talking about how AI is being used in these embedded systems that are part of the Internet of Things, IoT.
Spirit speaker.